Welcome back, everyone. Today's explainer tackles a massive, absolutely fascinating topic: advanced construction methods and equipment. We're diving deep into comprehensive university course materials, pulling from heavy-hitting texts by experts in the field like Halpin, Purifoy, and Rawlinson. If you have ever looked up at a towering skyscraper and wondered exactly how it all comes together without descending into total chaos, well, you are in the right place. Let's decode the blueprints of construction management together and turn these really complex engineering theories into clear, actionable insights.
Seriously, just think about that for a second. How on earth do you coordinate 10,000 individual, highly specific tasks without a single collision? We're talking about scheduling heavy machinery, pouring thousands of tons of concrete, wiring massive electrical grids, and managing hundreds of workers, all in the exact same physical space and often hundreds of feet in the air. Building a mega project is this incredible logistical and physical puzzle. It's a high-stakes environment where one single misstep doesn't just mean a minor headache, it literally cascades through the entire project.
Okay, let's dive into this. $1 million. On major international megaprojects, this staggering number represents the potential financial cost of construction delays, and that is per day. Let that sink in for a minute. Every single day a critical task is delayed, $1 million can just evaporate. That is exactly why construction management isn't just about hard hats and steel, it is a rigorous, highly disciplined science of time and resource control.
So here is the blueprint for our explainer today. We'll be moving through 5 crucial phases. 1. The foundation. 2. The master plan. 3. The resources. 4. The execution. And finally, 5. The shield.
Starting things off with Phase 1, the foundation, bidding and legal contracts.
Before a single shovel even touches the dirt, the rules of the game have to be poured and set in stone. Drawing on legal environment concepts from experts like Plutnik and Fajardo, we see that an abstract idea must systematically transform into a binding, high-stakes contract. Step 1 is preparing a comprehensive bid package, which includes the exact specifications, technical drawings, and contract requirements. Step 2 is the incredibly intense bidding process where contractors calculate their costs and compete for the job. And finally, Step 3 is the contract award and establishing the legal structure. The crucial takeaway here is that a skyscraper isn't initially built with steel. It's built on a foundation of airtight legal agreements and precise specifications.
Moving right along to Phase 2, the master plan. Planning, scheduling, and PERT.
Mapping out time is a project manager's primary defense against those catastrophic million-dollar delays we just talked about. To tame unpredictable timelines, managers use advanced analytical methods like PERT, or the Program Evaluation and Review Technique. As detailed in James P. Lewis's Project Planning Methodologies, PERT doesn't just list tasks out. Instead, it analyzes the sequence of events and estimates the time required for each, especially when you're dealing with high levels of uncertainty. It allows managers to actually see the critical path. That's the sequence of tasks that, if delayed by even an hour, will push back the entire completion date.
And this brilliantly illustrates how we visualize that critical path. There are 2 primary ways to draw a network diagram. First, in the activity on arrow, or AOA method, the arrows themselves represent the actual tasks, while the circles just mark the start or finish events. Alternatively, in the activity on node, or AON method, the task lives inside the node itself, and the arrows simply show the logical sequence or dependencies. Today, modern software heavily favors AON because it's just highly intuitive, You look at a box, that's your task, and the arrows simply tell you what must happen next.
And all this scheduling, it builds right up to the ultimate, incredibly tense boardroom decision, the time-cost trade-off. Imagine you're managing a high-rise. Weather has put you a week behind. Do you pay double for overnight expedited concrete delivery and weekend overtime labor to catch up? That's what we call crash time. Sure, your direct costs skyrocket, but if you stick to normal time, your schedule stretches out. And your indirect costs, like renting the cranes, paying management salaries, and just general site overhead, they just keep bleeding money. It is a constant razor-thin balancing act.
Which brings us to Phase 3, the resources, estimating costs and manpower.
So our schedule is framed out, but now we have to map the actual lifeblood of the site, the money and the labor. This brings us to quantity surveying and takeoff. Deeply rooted in the texts of Pratt and Fajardo, estimating is absolutely not guesswork. Not at all. It is a grueling, extremely precise calculation of every ounce of material,
every single hour of labor, and every piece of equipment required. It is the strict financial bedrock of the project. If a quantity takeoff is off by just a few percentage points on a massive project, the contractor could literally end up losing millions of their own money.
Without proper planning, you get these completely chaotic labor demands, huge spikes followed by deep, unproductive valleys. Imagine hiring 1,000 workers for a Tuesday, only to have 800 of them standing around idle on a Thursday with absolutely nothing to do because the preceding tasks aren't finished yet. Resource leveling is the analytical technique of shifting non-critical tasks around within their allowed float times to smooth out that demand. It creates a steady, consistent, and much more cost-effective workforce.
All right, let's get into Phase 4, the execution, equipment, and field operations.
Okay, the plans are perfect, the resources are fully leveled. Now we finally hit the dirt and steel. Heavy construction equipment operates on a relentless, honestly brutal life cycle. Referencing Foy's foundational principles, machinery isn't just a one-and-done purchase, it's an ongoing operational science. From procurement in month 1, right into heavy field operations by month 3, you absolutely have to factor in mandatory routine maintenance by month 6. Why? Because if you push an excavator past its schedule just to save a little time today, it will absolutely punish you with a catastrophic breakdown tomorrow. By month 24, you're constantly analyzing whether the cost to keep repairing the machine is higher than its total replacement value. Because at the end of the day, field efficiency dictates the bottom line. You can have the best master plan in the world, but it all comes down to a few core productivity variables. Labor efficiency and motivation. Are the crews actually working well together? Equipment output capabilities. Are you using the right-sized crane for the load, or are you bottlenecking yourself? Operational cycle times. How many minutes does it take a dump truck to load, haul, dump, and return? And of course, there are always unforeseen site delays, like sudden storms or hitting unmarked bedrock. Managing execution means relentlessly optimizing these variables on the fly.
Finally, we arrive at Phase 5, the shield, quality, safety, and disputes.
As we push toward project completion, we need to slow down for a second and talk about the critical systems that protect the entire operation. Inspired by Steve Rowlandson's extensive work on safety management systems, this thought really captures the absolute emotional and physical gravity of a construction site. Safety management is not merely a regulatory hurdle. It is the ultimate protection of human life in high-risk environments. When we are discussing heavy equipment, towering heights, and high-voltage systems, safety just cannot be an afterthought tacked onto the end of a schedule. It is a core pillar of the whole shebang. To actually prevent these disasters, both structurally and humanly, project managers deploy a whole network of protective systems. It starts at the very beginning. Quality planning ensures the processes are right from the start, while quality control involves physically checking things like concrete strength and weld integrity. It's an active process too. Hazard identification protocols and active safety monitoring ensure that the site adapts to daily dangers. And tying it all together are robust information management systems, ensuring every single inspector, manager, and worker is operating from the exact same safe procedures.
But even with perfect planning, rigorous safety, and elite execution, human endeavors on this scale are incredibly complex. Changes in scope, unforeseen weather, or material delays, they inevitably lead to friction. And that brings us to construction disputes. Resolving these isn't about yelling on a job site, it's about returning to that initial legal foundation we established back in Phase 1. Navigating mediation, arbitration, or litigation requires structured legal resolution to finally, officially close the project lifecycle and cross that finish line.
We've journeyed all the way from legal bidding and PERT charts to resource leveling, heavy equipment cycles, and vital safety systems. It is an intricate, incredibly high-stakes dance. So I'll leave you with this thought. Next time you walk into a skyscraper or drive over a massive bridge, look past the glass and the steel. Ask yourself, what invisible critical path, what incredibly optimized schedule, and what perfectly balanced resources are secretly holding it all together? Thank you so much for joining me on this explainer, and I really encourage you to keep questioning the amazing built environment all around you.